According to the National Electrical Code, Section 314.23e and its exception, the use of a 1-inch LB conduit body with 3/4-inch or 1/2-inch pipe is permissible under certain conditions. Section 314.23e addresses the support of rigid metal conduit or intermediate metal conduit when run exposed on ceilings or walls. The code states that when these conduits are supported by a messenger wire or by metal straps, with only one conduit, smaller in size than the messenger wire or metal strap supported on each strap, the messenger wire or metal strap can be considered the equipment grounding conductor. Now let's dive into the exception. The exception to Section 314.23e specifically addresses Schedule 80 rigid non-metallic conduit or intermediate metal conduit. It states that conduit not larger than 1 inch in size does not require an equipment grounding conductor when supported by messenger wire or metal straps. This exception is crucial because it directly relates to the question of using a 1-inch LB conduit without needing a separate equipment grounding conductor in this specific scenario. To understand the implications, it is important to break down the key components of the code section and its exception. Firstly, consider the type of conduit. The exception explicitly mentions Schedule 80 rigid non-metallic conduit and intermediate metal conduit. This means the rule applies only to these specific types of conduit, not to others like rigid metal conduit unless falling under the main rule in 314.23e where the support acts as the ground. Secondly, consider the size limitation. The exception is valid only for conduit not larger than 1 inch in size. This is a critical factor when evaluating whether the exception applies to a particular installation. Thirdly, think about the support method. The conduit must be supported by messenger wire or metal straps. The way the conduit is supported plays a significant role in determining whether the exception can be used. If the conduit is supported in a different manner, the exception may not be applicable. Now, to address the original question, since the exception allows for 1-inch conduit without an equipment grounding conductor when supported by messenger wire or metal straps, it implicitly supports the use of a 1-inch LB conduit under the same conditions. The LB conduit body, being a fitting used to change direction in a conduit run, is considered part of the conduit system. Therefore, if the 1-inch conduit run meets the conditions outlined in the exception, the 1-inch LB conduit body within that run is also covered by the exception. It is important to note that while the code allows for this configuration under specific circumstances, it is crucial to ensure that all other aspects of the installation comply with the NEC. This includes proper conduit fill, secure connections, and adherence to all other applicable codes and standards. Here is an example. Imagine you are running a 1-inch Schedule 80 rigid non-metallic conduit along a wall supported by metal straps. According to the exception in Section 314.23e, you do not need to run a separate equipment grounding conductor. Now, if you need to make a 90-degree turn in this conduit run, you can use a 1-inch LB conduit body. Since the entire run, including the LB conduit body, is 1 inch or less and is supported by metal straps, the exception still applies, and you are not required to install a separate equipment grounding conductor. However, it is important to ensure that the metal straps are properly connected to a grounding system to provide a path for fault current, if one were to occur. Another consideration is that while the exception waives the requirement for an equipment grounding conductor, it does not eliminate the need for grounding altogether. The metal parts of the electrical system must still be grounded, typically through the service equipment grounding system. The purpose of an equipment grounding conductor is to provide a low impedance path for fault current to return to the source, allowing the overcurrent protection device, such as the circuit breaker or fuse, to quickly trip and clear the fault. When the exception in Section 314.23e is used, the messenger wire or metal straps serve as the equipment grounding path. Therefore, it is essential to ensure that these supporting structures are adequately sized and properly connected to the grounding system. It's worth noting that the NEC is a comprehensive document, and electrical installations must comply with all applicable requirements, not just the specific section discussed here. Always consult the latest edition of the NEC and seek guidance from a qualified electrical inspector or engineer to ensure compliance with all applicable codes and standards. In summary, the NEC supports the use of a 1-inch AB conduit body with 3/4-inch or 1/2-inch pipe under the conditions outlined in section 314.23e exception, specifically when using Schedule 80 rigid non-metallic conduit or intermediate metal conduit not larger than 1 inch, supported by messenger wire or metal straps. This exception waives the requirement for a separate equipment grounding conductor, provided that the supporting structures are properly grounded. Always refer to the latest edition of the NEC and consult with qualified professionals to ensure safe and compliant electrical installations. Furthermore, it is crucial to understand the terminology used in the National Electrical Code. For instance, the term equipment grounding conductor has a specific meaning, referring to the conductor used to connect the non-current carrying metal parts of equipment to the system grounded conductor, the grounding electrode conductor, or both. Its purpose is to provide a low impedance path for fault current. A grounding electrode conductor, on the other hand, connects the system grounded conductor or the equipment to a grounding electrode, such as a ground rod or metal water pipe. The grounding electrode provides a connection to the earth, helping to stabilize the voltage to ground and provide a path for lightning and other transient voltages. Understanding these terms is essential for correctly interpreting and applying the NEC. In addition to the specific exception in section 314.23e, it is also important to consider other relevant code sections that may apply to a particular installation. For example, section 300.3b addresses the installation of conductors in the same raceway, cable, or enclosure. This section generally requires that all circuit conductors, including the equipment grounding conductor, be installed together in the same raceway or cable. However, the exception in section 314.23e allows for a deviation from this requirement, as it permits the equipment grounding path to be provided by the messenger wire or metal strap supporting the conduit. It's also essential to consider the ampacity of the conductors being installed in the conduit. The NEC provides tables that specify the allowable ampacity of conductors based on their size, insulation type, and the ambient temperature. The conduit fill, or the amount of space occupied by the conductors in the conduit, must also be considered. The NEC limits the conduit fill to prevent overheating of the conductors. Another factor to consider is the type of environment in which the conduit is being installed. If the conduit is exposed to corrosive conditions, such as in a chemical plant or near the ocean, it may be necessary to use special corrosion-resistant materials. Similarly, if the conduit is being installed in a hazardous location, such as an area where flammable gases or vapors are present, it must be installed in accordance with the requirements for hazardous locations. The NEC provides detailed guidance on the types of wiring methods and equipment that are permitted in hazardous locations. When installing conduit, it is important to use proper installation techniques. This includes using the correct tools, making secure connections, and properly supporting the conduit. The NEC specifies the maximum spacing between conduit supports to prevent sagging or damage to the conduit. It is also important to ensure that the conduit is properly bonded to provide a continuous electrical path. Bonding involves connecting metal parts of the electrical system together to ensure that they are at the same electrical potential. This helps to prevent shock hazards and provides a low impedance path for fault current. In addition to the NEC, it is also important to comply with any local codes or regulations that may be in effect. Local codes may be more stringent than the NEC in some cases. It is always a good idea to check with the local electrical inspector to ensure that your installation complies with all applicable requirements. Finally, remember that electrical work can be dangerous. Always take appropriate safety precautions such as wearing personal protective equipment and energizing circuits before working on them. If you are not comfortable working with electricity, it is best to hire a qualified electrician. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with qualified professionals and refer to the latest edition of the NEC to ensure safe and compliant electrical installations. In addition, always remember to check with the local authority having jurisdiction, or OJ, as they may have additional requirements or interpretations of the NEC that must be followed. Their rulings take precedence. Furthermore, be aware that product listings and labeling play a critical role in electrical safety. Only use listed and labeled equipment that is suitable for the intended application. Listing and labeling indicate that the equipment has been tested and certified by a recognized testing laboratory to meet certain safety standards. Using unlisted or unlabeled equipment can be dangerous and may violate the NEC. Also, be aware of voltage drop in long conduit runs. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source due to the resistance of the conductors. Excessive voltage drop can cause equipment to malfunction or fail. The NEC provides guidelines for calculating voltage drop and recommends measures to minimize it, such as using larger conductors or installing additional circuits. Also consider the impact of harmonics on electrical systems. Harmonics are distorted waveforms that can be produced by nonlinear loads such as electronic devices and variable frequency drives. Harmonics can cause overheating of conductors and equipment, as well as other problems. The NEC provides guidance on how to mitigate the effects of harmonics, such as using harmonic filters or oversized conductors. Remember to keep accurate records of all electrical work performed. This includes drawings, specifications, and test results. These records can be useful for troubleshooting problems and for future reference. It is also a good idea to take photographs of the installation before it is covered up. Photos can be helpful in identifying the location of concealed wiring and equipment. Always prioritize safety when working with electricity. Take the time to plan your work carefully and follow all applicable safety procedures. If you are unsure about something, ask for help from a qualified professional. By following these guidelines, you can help to ensure safe and compliant electrical installations.